Good morning everyone and welcome to my talk, Automate Your Inner Scout. My name is Peter Streef and I'm a staff software engineer at Modern. I've been a scout for the better part of my life, which makes me quite familiar with the Scout's rule. Always leave something in a better state than you found it. A logical application for this would be on the campground. There's this systematic way that we use to clean the campground after a week of camping in the woods. We would line up on one side of the campground next to each other, with about 2 meters between each other, and then walk to the other side, collecting all the garbage while we were going, picking up everything between you and the person next to you. And by collecting all the garbage, we would ensure the Scout's rule. But you're not here to talk about the woods, I bet. It was quite some time after that first campground cleaning that I found the Scout's rule in a different context, code maintenance. The application of the Scout's rule in code looks a bit like this. First, you decide on what a better state looks like. For instance, let's stop using this deprecated method and use the new one instead. And then, when you visit the code that uses it, you update it while you're there. And in principle, this is a good thing. It's a natural way to maintain your code. But I've also saw it being used as a way to postpone work. We'll just scout that away later. I've never actually gone out to a campground myself to clean up without staying there myself, so maybe it still fits though. Like keeping the pressure in your car tires and periodically changing the oil, code needs to be maintained as well to keep it running smoothly. When we run behind on our migrations, we as developers will in the end be held responsible. And you don't want to be waking up in the middle of the night about a potential vulnerability and figure out that you have to do a major framework migration to mitigate because your version isn't supported anymore. So what if we could automate the Scout's rule? What if we could leave our code in this better state the moment we decide what the better state looks like? That would be like installing robot vacuums on our campsite. Enter Open Rewrite. Open Rewrite is an open source tool to automate code maintenance, which is maintained by Modern, the company I work for. It started at Netflix to migrate from an internal logging framework to SLF4j, which is a standard in Java. And it has since been built into an ecosystem to maintain and modernize code in many languages and frameworks. Open Rewrite uses a defined set of steps called a recipe to execute the code transformations. And these can be small recipes, like change one import to another, or very complex, like full-blown framework migrations. Most recipes are built up out of smaller recipes that can be used like building blocks to craft complex migrations. Take, for example, our Spring Boot 3 migration. This recipe consists of 1,600 steps, smaller recipes, to achieve the required transformations. Spring upgrade 3.2 depends on 3.1, which depends on 3.0, which again depends on an upgrade of Java itself to level or version 17. And this Java 17 migration itself, it doesn't only update the language level, making your code compile, but we also, where it makes sense, introduce new language features like text blocks and string formatted, for instance. We also ensure that your CI system is updated, so that, for instance, your GitHub workflow will actually still build your application. And this makes the change as complete as possible. We consider two types of changes that can be accomplished through Open Rewrite recipes: push-based and pull-based. A push-based change is a simple upgrade that we do routinely, such as a Gradle wrapper update, static code analysis, code formatting or other style changes, or fixing a vulnerability. These recipes perform a 100% accurate change. And once trust has been built in this accuracy, you can actually merge this change without a deep review of the code. On the other hand, we have the pool-based changes. These are much more complex, and for instance, like the framework migration we saw earlier. These recipes might not fix every single use case out there, and the results need to be closely reviewed. You might have to do some additional work there to get the migration over the finish line. However, usually 90% of the work has already been done for you. An example of such a change you might still have to do is when a third-party library integrates with a framework, but just there isn't the recipe for that just yet. And then you have the choice, either you migrate it manually or write a recipe yourself and contribute. Another way of separating these two is between ongoing maintenance and one-off migrations. To be able to achieve these accurate and targeted changes, we need a specialized representation of the code. Open Rewrite turns your code into what we call a lossless semantic tree, an LST. This LST preserves not only the code itself, but also the style and comments, for instance. Open Rewrite uses this LST to do targeted changes using recipes, and this results in a diff that will look very much like it was written by one of your teammates. Open Rewrite can do much more than conventional find and replace kind of solutions, because it doesn't understand only your code, but thanks to type attribution, it also knows everything about the types you use from your code and from your dependencies. Here we can see an example of a JUnit 4 to 5 migration. There are some simple changes required, like change one annotation to another, and some changes are more complex. JUnit 4, you could define an exception that would be thrown by the test itself. And then the test would verify if indeed that exception was thrown, making the test pass. In JUnit 5, that was changed to a method that would catch the exception and then validate it, the assert throws. There's an advantage here that you can actually make sure that a very specific piece of your test throws that exception. Good luck doing a change like this with a find and replace regular expression. We estimate the time that such a change takes to about 5 minutes. If you have to do this across your entire code base, that's going to add up quickly, up to days of work. Many individual developers are discovering and introducing Open Rewrite within their organizations. Open Rewrite can be used on the developer's machine, enabling them to do automated code maintenance on a repository by repository basis. The open source tool is like a robot vacuum that you can bring along to reduce hours or reduce days of work into hours of work. But we can go a step further, changing hours into minutes by applying these changes across an entire organization at the same time. Modern has a commercial SaaS platform that takes automated code maintenance to the next level. It uses the same open source recipes. However, the LSTs, they're serialized and saved, in contrast to Open Rewrite, where they're generated for every recipe run. This makes recipe running much faster, and we can work on even larger repositories. Modern platform enhances the user experience and offers much more tools to give full insight into the state of your organization's code. You can find call paths throughout all your organizations or all your repositories, applications, to figure out where specific methods actually go. You can list all your dependencies across repositories, including vulnerabilities. This might make your security officer pretty happy. You can use a CLI that we bundle with the SaaS to our customers, and you can do cross-repository transformations locally, and much more. With Modern, it's like having these robot vacuums installed on every campsite at the same time. There are many examples of code maintenance that Open Rewrite and Modern already can automate for you using existing recipes. You're probably well aware of most of them as you've spent hours, if not days, working on this manually. I've listed a few. You have your code style changes, your static analysis changes, finding and fixing deprecations or vulnerabilities, finding and fixing breaking API changes, and the full-blown framework migrations. Today we're going to focus on fixing a breaking API change. I've prepared a demo called Scouting Modern Cookies, because everyone knows that scouting is about selling cookies, right? In this project, I'm going to make a breaking API change to the error handling logic. This is a cross-cutting concern that has been extracted into a library so that services can actually use it. So, how would you normally do this? Probably start with something like a Slack message saying, hey, I've got this new amazing functionality, please migrate. Then you hear from other teams, yeah, no time, other priorities. So instead, you'll probably just deprecate the method and add a new one instead. And then you start hoping that maybe in the next year or so, people will actually migrate to your method so you can clean up. Instead, we're going to use the Modern platform to see if we can do this in an automated way. I'm going to start with an impact analysis. I'm going to select a recipe from the marketplace. We'll run that recipe, fixing the code and inspecting the changes. And finally, we will mass commit and merge our changes so they're ready to go to production. Switch screens. Right. So I've prepared a pull request, same change as you just saw in the presentation, where I'm adding this integer status field. So instead of always returning an internal server error, we can actually steer these changes to set the status on the response if a specific exception is thrown. So this is the Modern platform. As you can see, we have quite a few organizations or projects already loaded in. And we have already 2,300 recipes now. This changes every week. Many organizations, as I mentioned, like these open source ones, where you can already run these recipes on. I have selected Scouting Modern, the project that I have created for this demo. This organization looks like this. We have a core library, where I'm actually making the change, and 4 services. I've only made 4, but this could easily be 1,000 ones as well, if your organization is bigger. So, we're going to use the find method usage, the Java one, to figure out where the method I'm changing is actually used. I need to supply a method pattern. So this is the constructor on API error, taking 2 string arguments. I don't care about overrides right now, so I'll leave that as default. So recipe is running now, and we can see that the results pop up pretty quickly. We can inspect those results, and indeed it found the constructor I'm looking for. Now if I had 1,000 different repositories in here, I wouldn't want to go in and check these results separately. So instead, let's generate a data table. This data table is an Excel-based data table or sheet that will show us all the methods that are being called throughout, or where this method is being called throughout all our applications. As you can see here, for all our repositories, we can see down to the source file level where the method is being called, including the actual content of the arguments. So now that we know, like, this is a migration that we can actually do, let's choose a different recipe, the add literal method arguments. I have searched for them before, so I'm just going to use that. And this takes the same method pattern, because we're looking for the same method, of course. And we have to supply some more information, like I want to add after the second argument, this is 0 base, so 2. I want to add a 500. 500 implies an internal server error, and we don't want to actually change the functionality in our consumers. We also have to supply the type of this argument, and that is for the type attribution I mentioned earlier. If this recipe was a part of a bigger recipe, then we need to know the type of this field to be able to change it further if needed. So let's run it. You can see that we get the results again. So let's inspect. And now instead of just finding the method, we see that we actually made a change. We added this literal argument to it. And I trust this recipe, so I'm just going to go ahead and create a pull request out of it. So now the platform is actually pushing the changes to GitHub and preparing these pull requests, which we can also see. So here is the same change that you saw earlier, but then on GitHub, ready to go. Now, I could also approve these changes to the platform, or maybe more likely ask a teammate to approve it for me. But I didn't set up this project to require it, so I can actually immediately go and merge. But I will first merge the actual change to the library. And then I can merge. I'm going to use squash. I'm going to delete the branches. Like, let's ensure the scouts rule here as well, right? And there we go. Now our changes are being merged. It's processing. First one's already through. And the rest will soon follow. So now I've shown these changes within the platform, but to show you in a maybe more familiar environment, I'll also show them locally. For that, I'm going to use our modern CLI. Our modern CLI can be used by our customers to do the same things that I just showed on the platform locally. Running recipes, creating data tables, it's all possible. It also contains some Git commands. So right now I'm going to make sure that everything is going to be checked out in main. And what is everything? Everything is the repositories I showed on the platform. I've also checked them out locally. So we'll find the repositories and do these operations on them. I'm now going to make sure that I pull in all the changes from Git or GitHub. There they go. And because I haven't set up any artifact registry where this is going to, I'm just going to cheat a bit, go in here and publish the changes to my library locally, so I don't have to download it from the internet. And now I'm going to use mod again to do an arbitrary command in the current directory on all the repositories it finds. In this case, I'm going to build using Gradle. And you can see that all these repositories still build successfully. And to see exactly what we have built, here we see the actual change to this constructor we made. Indeed, it now has an API or a status field in it. We can see the error handling logic is updated. It now uses the status code. And also here we can see that the 500 has been added in the consumer. All right. So we have seen now that we can analyze impact by finding these method usage throughout our organization's code, where it's used and what it looks like, down to the source file where it's defined in. We recently worked with a customer to improve this even further. So we built a detector that could detect breaking API changes and then just send a message, a comment on the pull request saying, hey, you're about to break your consumers. maybe you should figure out a recipe to run and actually upload those as well. We have updated the code of our consumers in a matter of minutes. And we've committed the changes back to GitHub. No review was required in this case because of the way it was set up, but we could have done that through the platform as well. And then we merged our changes into production, or they could be going to production. So you can now be as an overlord to an army of robot vacuums keeping your company's code up to date. And you won't even have to bother the teams that maintain these services so they can focus on developing features. Forget about being a 10x developer. With Modern, you can be a 100x developer. And with that, we're at the end of this presentation. Here are some resources that you can use to learn more. We have extensive documentation and tutorials, both on Open Rewrite and Modern. If you're interested into contributing to Open Rewrite, you can find us on GitHub. If you want to try some of these recipes or other ones, we have a lot, you can go to app.modern.io. That's where I just was as well to run all these recipes on. If you have any questions, you can reach out on our public Slack or send an email. Thank you very much.